G'day people. Just thinking about all the crap I was getting the other day about using engineering techniques for my woodworking, and I thought, how can I really wind these guys up that don't like the idea of doing a good job? And I thought, I'll apply some more engineering methodology to my woodworking just to get them really wound up. So here we go, guys. Tennons, how to get an accurate tenon. How I would do it as an engineer, or how I'd check the component as an engineer, is like this, using a DTI and comparators. So DTI is not a measuring instrument, it is a comparator. It's used for comparing something of a known size to something else. So here we have some gauge blocks, and they're set up to either side of my tolerance for my component. And my inspection table here is just a piece of float glass. It's flat enough, certainly, for woodwork. I accept some of what you guys are saying about accuracies and it not being that important for woodwork. Doesn't stop me from, however, from wanting to do a good job. So if we watch the dial here, you can see that's moved up. So we've got one end of my tolerance to the other, and my work is pretty much there, smack bang within tolerance. Oh, sorry, bad camera work. At almost no point at all does it pass outside the tolerance. And that tolerance, by the way, is 0.1 millimeters. I've got no idea what that is in inches for you Imperial guys, but 0.1 for woodwork is, it's not bad actually. It's not bad tolerance, is it really? I'd be quite chuffed if I could. Oh, I can do it, and I do it because I've got this method of doing it. So if I check my dimensions as I'm doing this job, and I've measured the thickness of material I'm removing with my plane. This is a very nice skewed Stanley plane that I've got. So for doing the corner of a tenon, I can actually take across right up to the shoulder. But I know that that's taken away 0.1 of a millimeter each shaving. So if I check the dimensions on here and look where I'm high, I can actually remove a slither of timber from the exact correct place, and I can ensure that this face is parallel with my datum face at the bottom. And so I've got this tenon exactly flat, exactly the right dimension. Everything is for metalwork, of course, this would be a wide open tolerance and it would be considered to be fairly inaccurate, but for woodwork it's considered to be extremely accurate. And do you know what? It's quicker. It's actually quicker to do it this way than it is to saw it, try it in the hole, take it out, shave it down a bit, guess where it might be high, guess where it might be low. With this method, I don't have to do any of that. I can make it the right size first time, very quickly, and then just stick it in the mortise. And it works for me. However, I actually do use the Festool domino anyway. So although I can do this, Festo domino is a lot quicker than this method. But anyway, I hope that really annoys those of you that don't like accuracy, and I really hope it pleases those of you out there that actually do like the idea of doing a bit of accurate work and like the idea of a bit of engineering technology being applied to woodworking. So anyway, speak to you later.